doubt, questions, confusions? For the calculation was clear. Okay. So in that case, I can say that is it possible for you to prove, if I want you to prove that if a matrix has n1 repeated eigenvalue of lambda 1, n2 repeated eigenvalue of lambda 2, n3 times repeated eigenvalue of lambda 3, and so on, then what will be the solution of the what are the eigenvectors? What are the solution? So if I say that dx dt equals to ax and it has got lambda 1 n1 times, lambda 2 n2 times, and lambda nn times, and n1 plus n2 up to nn equals 12. We can put I1, otherwise 2 times is confusing. I1, I2, In equals 12. We can put lambda m much better. I1, I2, In equals 12. What will be your xt? Generalized solution. Any idea? What will be the xt? Lambda 1 is repeated I1 times, lambda 2 is repeated I2 times, and lambda n is repeated In times. And a matrix is non-symmetric. Of course, generalized eigenvectors will be there. I didn't say that a matrix is non-symmetric. How to get generalized eigenvectors? How to get the x solution? Okay. So this will be one of the exam questions in quiz. We have done yesterday in the class, we have to have generalized concept. So this is coming in this type of proof will come in the second quiz. So I have given one question of second quiz. Okay, so think about it and get the answer. So now we will be going, what we have done, we have done dx dt equals to x. And our solution, direct solution, xt equals to e to the power ta into c. Okay. So now I will be going for the two parts today, and today we will be finishing dx dt equals to x, because enough of this we have done so much. In fact, complete details of this analysis, that much details I think nobody can do. So, what actually we are planning to do now? System of equations with the periodic coefficients. System of equations with periodic coefficients. System of equations with periodic coefficients. So please write down the theorem. A necessary and sufficient condition. A necessary and sufficient condition. A necessary and sufficient condition for a system. For a system x prime bar. For a system x prime bar equals to ax. A necessary and sufficient condition for a system x prime bar equals to a double prime x. Ax to admit a non-zero periodic solution. To admit a non-zero periodic solution. To admit a non-zero periodic solution of period omega. Of period omega. Omega we write this way. Period omega is that the matrix I minus. The matrix I minus e to the power omega is singular. So I repeat once again, a necessary and sufficient condition for a system x prime bar equals to ax to admit a non-zero periodic solution of period omega is that the matrix I minus e to the power omega a is singular. How to start this problem? The last assignment problem actually. I am discussing it. How to start this problem? Non-zero, what is called periodic solution? Any idea what is called periodic solution? What do you mean by period? Huh? Yeah.
Function which repeats the solution after a
certain time. That means you have done it 10 plus 2. 10 plus 2, this kind of things you have done. It's called wave. Okay? And you see that this entire thing is repeated here. How long? After how long? 2 pi. Right? So this is called the phase stage. Okay? So somewhere you can see the maximum amplitude is the minimum and so on, and when it's positive is negative. But the entire wave is again repeated here. So whatever the state is, the same state is here. So okay. So after say if it is time is actually there, so t plus 2 pi it will repeat. Then t plus 4 pi, t plus 6 pi, each 2 pi things will get repeated. That means what is said here, x bar t equals to x bar t plus omega. Because omega is a period, and 2 pi is a period. Period definition in physics is the state will repeat in a particular time interval. That is called period. For here it is 2 pi. But our question is given omega. Okay? So that's why I am writing x bar t equals to x bar t plus omega. In general it is x bar t plus omega. Okay? So now it is said that this is the periodic solution. The question is, the periodic solution is valid. I minus e to the power omega is singular. Okay? So in that case, what actually happens? Our solution from here is x bar t, which is e to the power ta into c. And x bar t of t plus omega, it will be e to the power t plus omega a into c. It is e to the power t a e to the power omega a into c, which is x bar t plus omega, which is also equals to x bar t, periodic solution, which is nothing but e to the power ta into c, e to the power ta e to the power omega a into c. And you, what you get, if you just take this here, okay, or if you if you do the inverse minus t, so t or to the power minus t, or you can actually say that e to the minus t. So in that case, what you will get, e to the power, so e to the power ta c minus e to the power ta e to the power omega a. You don't have to do anything actually. Directly you can do that. If you are so much confused, you directly you can do that. Change the sign. Why you take inverse and all. And then, so far you have not done anything. No inverse, no matrix multiplication, nothing. You just did substitution. Okay? And e to the power ta c, you can just take common. And anything you can multiply by identity matrix. That you know that. So if you take it common, don't put 1. Because everything is matrix and vector. So minus e to the power omega a equals to 0. E to the power ta cannot be a null matrix. In that case, there is no point to solution. Okay? So e to the power ta, of course, they are not equal to 0 matrix. Okay? So what actually happens? And c cannot be 0. If c is 0, there is no point. C is the constant, right? C should not be 0. C is non-zero. And what actually happens for this case, if it is this, then what we will get from here? I minus e to the power omega a. In fact, it should be written this way. Otherwise, it won't make sense. Because we don't go, the substitution will not go. So, I minus e to the power omega into c equals to 0, and if c has to be non-zero, we have done earlier in the class. If ax equals to 0, if If x is non-zero, it has to be singular, right? So I minus e to the power omega a has to be singular. So that means x prime equals to x will admit the periodic solution if and only if I minus e to the power omega a matrix is singular. Any questions, any doubts? Okay, that's one of the interesting parts. So now we will be going the same situation for ax plus b. What will happen? So before that, we will try to write down what will be the solution for this case. Direct method. Let me see who can give me the answer. Direct method, what is the solution? Direct method, what is the solution? Direct method, x bar t equals to, you can easily do it. You don't have to do it. It is one step. You need to find integrating factor and that's it. Direct method. It is direct method. P should not come. How P? You are just dictating from your notes. I am doing direct method. I don't know P. In direct method, what you do to dx is equals to x, e to the power t into c. No. Where is P coming? Pardon? C1 will not come. How C1? If this is not there, what is the solution? E to the power t into c. Then why C1, C2 are coming? The e to the power t c will be there already. The first term, right? So first term is already there. E to the power t c. I don't know why so much problem. The simple things you are not able to do. In fact, if you don't know, you can do integrating factor and get to the answer from here directly. dy dx plus py equals to q. Py plus q. If you do integrating factor, you know that. What's the integrating factor here? E to the power minus 3a. That's the integrating factor. Integral 0 to plus integral 0 to t, then e to the power t minus tau a b of tau. That's all. Simple. This has been done already in the class. That's all. This is the solution. So this is the solution for the direct method. That's what Vasudha's question yesterday, right? You only asked me this question. What will happen for the direct method if there are BT term? This is the solution. Okay? So now I will state another theorem. Let Vt, which is just now V bar t, be periodic with omega. Let V bar t be periodic with period omega. Let V bar t be periodic with period omega. Then the solution x bar t is periodic of period omega. In the solution x bar t is periodic of period omega if and only if if and only if x bar 0 equals to x bar omega. Let v bar t be periodic with period omega. Then the solution x bar t is periodic of period omega if and only if x bar 0 equals to x bar omega. Okay? So we have to see that if the v bar t has a period, then in that case x bar 0 has to be x omega. So for a periodic condition, and we have to show here unique case and existing solution for a periodic solution. For a periodic solution, x bar t plus omega, which is x bar t, and at t equals to 0, x bar omega equals to x bar 0. Okay? So for a periodic solution, so this is one of the statement. It is quite obvious. There is some necessary condition and sufficient condition. So let's look at the sufficient condition. This kind of things actually we have to do it in mathematics. This proof and all may not come in the exam, but one has to know. If you think about exam, you can neglect this part, because I will ask you something which is dealing with theorem and lemma. Rather, I will do something which you can apply these theorems. So, given x bar 0 equals to x bar omega, from here, t plus omega is x bar equal to t, that is the periodic solution. And b bar t as a period omega. Now, another solution x bar, which is x bar t plus omega for all t. Okay, for all t. What actually happens if you do u prime t, which is nothing but x prime t plus omega? Am I correct? Okay. And x prime t plus omega is, you can see from here, which is from the equation dx dt equals to x plus bt is a x of t plus omega plus b of t plus omega. X t plus omega is nothing but ut, right? A ut plus, because b has the period. It was written bt has a period omega. That means b bar t plus omega, which is b bar t. Period omega, right? This is there already. So what we got, u prime t equals to ut plus bt. Now ut has a solution. So what actually happens? So ut has a solution, also a solution of t, and so what you have now, ut is also a solution. Ut is also a solution, which is u bar 0 x bar omega or x bar 0, which is given. So u bar t and x bar t, if you look at u bar t and x bar t, satisfy the same equation. Satisfy the same equation. If you put x prime t equal to ax t plus bt, ut and xt satisfy the same equation. But ut equals to xt plus omega. Okay, so x0 equals to x omega. Right? So it is possible because of this. Otherwise, you wouldn't have written this one. If this is not equal to this, then you cannot write x0 equals to x omega. So if the bt has a period, so when you talk about the periodic solution, dx dt equals to ax, then only thing matters xt plus omega to x omega. When you have a non-homogeneous term, you also have to see the periodicity. If this does not have period, the x bar solution will not have any period. Because of that only you can see x bar t equals to x bar t omega, this value, which is nothing but x bar 0 equals to x bar omega. Any confusion here? If it is not there, then this almost equality will not be valid. So periodicity solution is also dependent on the period of b bar. If this guy doesn't have period, if b bar doesn't have period, then we cannot talk about the periodicity of the solution. Any confusion, any doubts? It's very simple what we have done. We have assumed that x ut. So what we wanted to prove, we wanted to prove x bar q plus omega to x bar t. Okay? We wanted to verify. And that verification was possible because of this. Otherwise, if it is not, see AUT equals to BT directly, you can write xt. Right? Because xt satisfies this one. X prime t, if you look at x prime t, is nothing but axt plus b. Okay? Which is also u prime. And what is u? xt plus omega. Okay? So xt plus omega equals to xt. It was possible if and only if b bar t plus omega equals to b. So, to have the periodic solution for dx dt equals to x plus bt, bt has to have a period of omega. If the b doesn't have the period, there is a problem. You won't get periodic solution. Am I clear? I don't know how many of you understood, maybe 2-3, that will be sufficient because 2-3 are interested in the class. Because this way you won't get any of the books. What I am explaining is maximum explanation you can get in the class. Any doubts so far? Any questions? That's the problem. You guys don't have any doubts, but I am hearing that many people are not understanding many things. So I can't help it. Because I ask you for doubts, you don't ask the doubts unless 2-3 people are actually asking. Otherwise people are keeping quiet. I don't know. And did you understand, sir? Periodic solution? Okay. What's about you? I am just believing you. I am sure if I ask you, you won't be able to answer questions. That I am sure. Anyway, I always give benefit of doubt. Next statement. Okay, that's a very interesting statement. Please write down. We'll be talking about this one. A necessary and sufficient condition. A necessary and sufficient condition for the non-homogeneous equation. A necessary and sufficient condition for the non-homogeneous equation x prime bar equals to ax plus b bar t. A necessary and sufficient condition for the non-homogeneous equation x prime bar equals to ax plus b bar t, where b bar t is continuous and periodic with period omega. A necessary and sufficient condition for the non-homogeneous equation x prime equals to ax plus bt, where bt is continuous and periodic with period omega, to have unique periodic solution with period omega. To have unique periodic solution with period omega is that the homogeneous equation has no non-zero periodic solution of period omega. And repeat once again. To have unique periodic solution with period omega is that the homogeneous equation has non-zero periodic solution of period omega. A necessary and sufficient condition for the non-homogeneous equation x prime bar equals to ax plus bt, comma, where bt is continuous and periodic with period omega, to have unique periodic solution with period omega is that the homogeneous equation has non-zero periodic solution of period omega. Could you write it? Okay. We read the statement very carefully. Now read the statement very carefully. It is said bt is continuous function, periodic with period omega, and it has to have periodic solution of period omega. That means if this system has the periodic solution, then the homogeneous equation means x prime equals to ax will not have any periodic solution. How to prove it? dx dt x plus bt we have seen just now. It has periodic solution because bt has a period omega. If bt has a period omega, we found x bar t omega equals to x bar t. That means the solution x bar is periodic. If the solution of x bar is periodic for this non-homogeneous system, the question is, if I remove this one, I get homogeneous. In that case, the solution will not be periodic. How to prove it? Got my point? Yeah. You didn't get my point. First part. Second part. First part was okay. What I said, homogeneous means this part is gone. So what I got, x bar t omega equal to x bar t for this entire system. But if you remove this, that will that be periodic? That solution what you got? That's the question. How to prove it? How to prove it? So if x bar t plus omega is equals to x bar t for the non-homogeneous equation, it has been stated that there will not be having any periodic solution for the corresponding homogeneous system. That means dx dt equals to ax will not have any periodic solution. How to prove it? Very interesting part. How to prove it? So we are going to non-homogeneous system. How to prove it? Our general solution is given xt equals to the power tac plus 0 to t to the power t minus tau b tau d tau. Okay. Let's look at whatever so far we have learned. We can use them and do something. A necessary and sufficient condition. A necessary and sufficient condition for periodic solution. For periodic solution is x bar 0 equals to x bar omega. Okay? For this case, we have seen it just now. We have proved it. From here, what you get? If you substitute here x bar 0, what you get? X bar 0 equals to T0 means what you will get? Identity matrix you get. If you put T equal to 0, you get identity matrix. Because how to get identity matrix? I plus TA plus T square by T factorial and so on. Instead, except I, all the matrix entries T will be there. If T is put 0, other matrix, all the terms should be 0, we will be having identity matrix. Okay? So we will have I into C bar. When an integral will be having limit 0 to 0, this integral will not contribute, right? Yes or no? Okay? But what actually happens? This x bar 0 equals to x bar omega. So, what will you get? 0 to omega e to the power omega minus tau a b tau d tau. Am I correct? X bar 0 equal to x bar omega. So I can put in place of 0, I can put omega, right? In place of 0, I can put omega. So similarly, so what we did here, x bar 0 equals to c, first part. Second part is x bar omega. First thing is x bar 0, which is equals to c. X bar omega means e to the power omega into c, 0 to omega, omega minus tau and b tau b tau. Now the steps are very simple. Earlier I was trying to do everything in one step. I thought I don't want to put everything in one step. X bar 0 means 0, e to the power 0 is c, plus 0 to 0, if this integral will go, will become 0. Second part, x bar omega, e to the power omega c, 0 to omega, e to the power omega minus tau, b tau b. Yes? Agreed? Yes or no? Both the steps actually I have found. Now x bar 0 to x bar omega, that means this c should be equals to this. So c equals to e to the power omega a, c, 0 to omega, e to the power omega minus tau, a, b tau, d tau. Right? What to get next? So this term you can actually put it here, side change. Okay? So it will be I into C. I is the identity matrix. You put a vector. So I into C. So I minus e to the power omega into C. C is the vector which is 0 to omega e to the power omega minus tau. Sorry, a b tau, d tau. So now it is a solution. It is like, if you can think about Ax equals to b, it has a unique solution. What does it mean? What you can talk about matrix, nature of the matrix A. If the matrix A is singular, can you get unique solution? But you can get solution if matrix A is singular. What is the solution? No. What is the condition to get solution? If matrix A is singular.
Rank of the matrix, of the augmented matrix is equal to rank of A.
So rank of A augmented B equals to rank of A. In that case, you can get solution. The solution is not unique. The solution is not unique. Okay? Because the solution belongs to null space. Okay, null space solution cannot be unique. But if the matrix A is non-singular, it will give always unique solution. It has been proved by Fedon alternative theorem. Okay? It has been proved alternative theorem. So this matrix, this will give unique values of C. To get unique C, if your C is not unique, you won't get unique solution. If the solution is not unique, solution is no more valid. Solution has to be unique. And that means this matrix has to be non-singular. But that means what? So it implies unique for unique solution. For unique solution, this I minus e to the power omega A is non-singular. Is non-singular. I minus e to the power omega is non-singular. But what we have found, dx dt equals to ax, homogeneous solution. If it has a period xt equals to xt plus omega, we found I minus e to the power omega a is singular, but here are finally non-singular. That means if it is a periodic solution, that cannot be periodic for the dx dt equals to ax because the criteria is singular. We have just now proved for the first time in the first part of the lecture. So dx dt equals to ax plus bt, if it admits the periodic solution, okay, in that case the corresponding homogeneous system will not have a periodic solution, because homogeneous system has to admit periodic solution. In that case we need to have I minus e to the power omega a be singular. It is not becoming singular. Okay, in that case the homogeneous system will not have periodic solution. Think that is clear? Because you are not understanding. Now everything is clear, right? You don't have any periodic solution. Okay? Because you remember that the C has to be unique. If the C is not unique is a problem. You won't have the solution. If the C is not unique, the solution is not unique, and that we don't want. The solution is not unique, we don't want. Okay? The assignment problem now. Last problem, assignment problem set 5. So whatever you have learned, see this periodic part is very important in chemical engineering. Which chemical reaction, which part will apply this technique? There are some reactions, you may remember, it is there in the YouTube. Reaction is occurring, sometimes color is coming, color is going. Color is coming, color is going. What type of reaction? Autocatalytic reaction. To autocatalytic reaction, if it is first order, you can apply this technique. That's why I am teaching this one. Whatever I am teaching has got predicate, otherwise I will not teach mathematics. Because this course is mathematical methods and chemical engineering. So to see autocatalytic reaction, what is happening? This is the technique. Okay, what is autocatalytic reaction? A plus B is going to B plus C or something, the same reaction, okay? A plus B going to B plus C, okay? So in that case, if it is possible to have the, of course you have the nonlinear system, and nonlinear system you can do the stability analysis and all those things. And definitely, if I have time, I will be talking about the stability analysis also, how to apply stability and apply this techniques. But definitely, when you have the autocatalytic reaction, if you have the first order system, a first order approximation, definitely you can see that periodicity of the nature can be predicted from here. Let's look at the assignment problem. X double prime plus x equals to sine 2. X double prime plus x equals to sine 2. You all got the assignment, right? Show that xt is minus 1/3 sine 2t is a solution of the non-homogeneous equation of period 2 pi. Okay? So let's look at x double prime plus x equals to sine 2, and then I will have the x vector which is x1 and x2. So what are my differential equation? One is x1 equals to x, another is x1 prime, x2 prime equals to minus x1 plus sine 2. Am I correct? x1 prime equals to x2. So x2 is nothing but x prime, I can say. Okay? So I have two variables, x1 and x2. x2 is x prime, x1 is x. Can I write this way? Yes or no? Yes? Okay. What is the solution? x1. You can do directly. You can do directly. What is A matrix? What is A matrix? A matrix is what? 0, 1, minus 1, minus 1, 0, 0. What is B over T? 0 sin 2t. Excellent. Solution, we know that c e to the power t a c plus integral 0 to t. How to calculate e to the power t a? E to the power t a without, I will tell you another technique here. For shortcut, since it is 2 by 2 matrix, you can directly do that. No problem. What is A square matrix? Quick. A square. Give me the answer. 2 by 2 matrix. Multiplication. 2 by 2. I don't want to go by decomposition. No time. I directly do it. It's purely direct. Nothing you need. Yes, tell me. Minus 1. A cube. Quick. Purely direct method. Nothing I am assuming. Directly I am doing. Which is called as purely direct. A cube. 0. 1, 0. If I say a to the power 2n, what will be this from here? Can you compute? I have two systems, a to the power 2n, a to the power 2n plus 1. What is that? No, it should be in terms of n, no? Don't say minus 1, 0. It should be 2n. 2n means minus 1 to the, because if it is 2, it is minus 1. If it is 3, it is 0. This should be coming here. You cannot say minus 1 just like that. We cannot be minus 1 all the time. What is that? See, this 2n actually satisfies 2, 4, something like that. A to the power 4 will be also minus 1, 0, 0, minus 1. A to the power 5 will be 0, minus 1, 1, 0. A to the power 6 will be like this. A to the power 7 like this. So now tell me the answer.
Minus 1, 0.
Again you are saying minus 1, 0. It cannot be. Minus 1 whole to the power n. Okay, you do the calculation. So what you do, you calculate to the power 4. Can you calculate quickly? Because since you didn't calculate, that's a problem. A to the power 4, quickly. You tell me the answer. A to the power 3 into a. 1, 0. Are you getting 1, 0 or you are just telling from this expression?
1, 0, 0,
1, 0, 0. See, the sign is changing. That's why I am putting minus 1 to the power n. Okay. And 0, again 0 minus 1 to the power n. What will happen? Again the sign change will be there. It will be 2n plus 1. What will happen? 0 minus 1 to the power n. Minus 1 to the power. Question mark. 0. What is that? It is not 10. What is that question mark? N plus. Check it out at home. Okay. E to the power ta will be what? Direct. Purely direct. E to the power ta. Two by two matrix only. 1. TA means A matrix is having first entry 0. So 1 T will not be there. Then minus A square is minus T square by 2. A cube will not be there. A to the power 4 will be there. So T to the power 4 by 4 factorial. Okay, am I correct? And so on. Where is the term here? A matrix, it is 1 TA. This is clear or not? What I did. Next will be what? Here, please quickly. Minus T or plus T? Plus T then? Minus T cube by 3 factorial. Plus T to the power 5 by 5 factorial. Next is minus T plus T cube by 3 factorial minus T5 by 5 factorial. T minus T square by 2 factorial. It will go on. Plus T to the power 4 by 4 factorial. It is nothing but cos T sin T minus sin T plus cos T. And that says the matrix is non-symmetric. Cos T sin T minus sin T cos T. So if you see cos series, sin series, you can go back home and see Grevas book. You can see sin series, cos series, and this is the answer. Okay? Any question? What's the doubt?
1 minus
Sorry for the mistake. Okay. Now, what is the solution? This 2 by 2 system only, very quickly you should do. xt, which is e to the power ta c plus 0 to t e to the power t minus tau a b tau d tau. So, we will have e to the power ta, already we have seen, which is ta is cos t sin t minus sin t cos t. The c vector is c1, c2. What is the answer? It's a column vector. Tell me quickly, what is the column vector? E to the power ta into c. c1 cos t plus c2 sin t. Next, minus c1 sin t plus c2 cos t plus 0 to t. Then what we have? Cos t minus tau, sin t minus tau, minus sin t minus tau, cos t minus tau. B bar is given, which is 0, sin 2t, which is written here directly, and we have here d tau. Okay, so the final answer, you can go back home and do that, which is c1 cos t plus c2 sin t minus 1/3 sin 2t plus 2/3 sin t minus c1 sin t plus c2 cos t minus 2/3 cos 2t plus 2/3 cos t. You can go back and verify this, very simple. Okay. So now it is written that the solution is xt equals to minus 1/3 sin 2t. If it is, then what is your constant? What are the constants? These are x1 solution. We don't need this solution. We don't want. If we are found, fine. We want x solution. x1 is given is solution is minus 1/3 sin 2t. That is that. That means c1 has to be 0. And c2 will be minus 2/3. So if c1 equals to 0 and c2 is minus 2/3, what you get? If solution is minus 1/3 sin 2t, that's good. So you can we get the total solution, which is solution is this x bar is 1/3 sin 2 minus 1/3 sin 2t you are getting. Okay, and the non-homogeneous equation of period 2 pi. Okay, how to do that periodic solution? We can see that x bar 0 equals to x bar omega is satisfied because x equals to minus 1/3 sin 2t. And what is x prime? c1 equals to 0 and c2 is minus 2/3. Okay, so minus 2/3 cos t minus 2/3 cos t will cancel. It is 2/3 cos 2t. So your x bar vector is minus 1/3 sin 2t and 2/3 cos 2t. Okay, am I correct? And the 2t, that means if you have 2t plus 2 omega or 2 pi plus 2 omega, 2t. So sin 2 pi cos theta equals to sin theta. Am I correct? Cos 2 pi plus theta equals cos theta, right? So this is definitely having periodicity, which is the period is 2 pi. Yes or no? Periodicity is 2 pi. Okay, because we know that sin 2 pi plus theta equals to sin theta. Similarly, cos 2 pi plus theta equals to cos theta. Okay, so this has got the so that means if I put in place of 2 pi, this sign will not change, everything will be same. Okay, so this part is actually first part is clear. So that means the entire solution for the non-homogeneous case has a periodicity 2 pi. Next question. Non-homogeneous equation also acting non-trivial solution of 2 pi. How to find the non-trivial solution of 2 pi? How to find the non-trivial solution of 2 pi? If omega equals to 2 pi, what actually happens? Now we have to find the non-trivial solution. You have to find the non-trivial solution. If omega is 2 pi. If omega is 2 pi, what actually happens? You have to find the integral. I will take only 2 more minutes. If omega is 2 pi, is the periodicity. So right hand side we'll have 0 to 2 pi e to the power 2 pi minus tau a b bar tau d tau. What actually happens? This one you see 0 0. This one you get 0 0. Okay? And we all know that I minus e to the power omega c equals to 0 to omega e to the power omega minus tau b bar tau d tau. This we have already seen, second theorem I guess. Okay? We have seen now it is 0 0. That means what? That means what? I minus e to the power omega a has to be singular. That means very interesting. So, if it is period is 2 pi, that means you are not getting the periodic solution for the homogeneous system. But for non-homogeneous system, what actually happens? We can also have period pi. What does it mean? That means sine 2t plus pi. You can also write, right? Okay. So in that case, you have to see that there are two cases of situation here: 2 pi and pi. Both the case we can just verify. Both will be having periodic solution. But if you put 2 pi, it may not be satisfied for the non-homogeneous case. That could be the solution for the homogeneous case. But if you have the pi, that could be the solution for the non-homogeneous case. So last part I am giving you for your practice. I am not doing it. If you have any problem, you can do the last part. First two parts are very complicated. So with that, I am finishing the entry part, part, and next class will be using the functional